So chances are it's late in the night and you're watching this past paper video hoping that you get the answers to the past paper that you've been looking for all this time, and you're happy that it actually exists on YouTube. Well, don't leave it up to the YouTube algorithm to show you the rest of answers. I have an app that's called Learn It by makeITsimpleTT, and it has all the past paper answers in chronological order for the past 10 years, maybe 12, depending on the time that you're watching this video. It might have a lot more. The app is called Learn It. Go find it, download it. Link will be in the description. And if you want to see the PDF with the actual crap-o-foot handwriting that I have with the answers, so you could actually scroll through the PDF and look at the answers as it was written instead of watching the video, hey, you could do that too. Download the app now. Alright, back to the answers. Alright, let's go. Normal past paper mode as usual. We'll go through the answers. I'll explain them as best as possible. And hopefully you understand the answers and why the answers are the answers. Let's go. Question number 1. State one type of primitive data type and one example of a non-primitive data type. Primitive data types. In this syllabus, you learn about abstract data types in Unit 2. And abstract data types are ways of representing data in another way. So primitive data types will be ints. I'll put integer, float, char. Those are primitive. Arrays. We'll consider arrays primitive because they only hold one type of data. Well, sort of. Yeah. Yeah. Non-primitive would be stacks, queues, linked lists. A structure would kind of fall into primitive if you have structure, but a structure holds multiple types of data inside of it. So yeah, and you have to declare it and stuff. So don't try to mix up structures inside of this. Go to the far extremes. The extreme is integers, floats, characters, arrays. Those are the ones that you learn in Unit 1. In Unit 2, you learn stacks, queues, and linked lists. Wow, did I just sneeze there? Yeah. So stick to those and you should be okay. Concept of a stack. A stack is an array, or no. A stack is a list of items that use FIFO. FIFO, first in, first out, to order them. Yeah. To order them. What else do I to say? They are kept in check by a variable called top. Yeah, I can't say exactly what they want. Usually the FIFO part is what you're really looking for most times, but I don't want to act like I know exactly what the exact wordings are this for. Let me see if I can find a previous answer that would have gotten all the marks. Yep, list of items. That's what basically looking for, yeah. A list of items that uses first in, first out. Yeah. I put FIFO, FIFO. Right, yeah, they like to see that FIFO first in, first out, yeah. And they use a variable called top. And then if you want to just sprinkle some dust on it, just put in trim, push and pop, whatever, you know. They give you 4 lines, so make sure they know use push and pop operations. Spell operations with 1 P. OPPER. Operations looking wrong there. Operations. OP. Yeah, that's correct. Yeah. That was a bad moment. Yeah. So we looking for that, yeah. So if they're looking for FIFO, you're getting marks. If they get linear list of items, you're getting marks. If it asking you about if they have a variable called top, you're getting marks. If you use push and pop, everything that you know about a stack, right? Assuming that a stack goes to 100 integer items, okay, declare the variables that are needed for the implementation. So they want to know the variables that are needed. You need a variable called stack 100, which will be an array, and then you will need a top set to -1. Yeah. Yeah, you must have the top to -1. Did they say use? Oh, they say write C code. My bad. Oops. Then we have to put int in front of it. I feel they'll take away a mark if you don't do this. So don't Don't be like me and take it for granted that they understand that you know to put int in front of it, because it's numbers you're dealing with. So int stack, int up. Right, they don't want to lose that mark. Write C code to write a function that pops an integer from a stack and returns the value. Your function should not call any other functions. Okay, now this is a pop, so you have to declare it as an integer pop, but you don't have to send any values to the stack because they didn't tell it that it receives anything. So because they're not receiving anything, you just move on into life as normal. So in pop, the first thing you have to do when you have to do a pop is create a variable. So int value, yeah, something like that. Right, to go through a stack, you have to check to see if it is not, for pop, you have to check to see if it is not empty. Yeah, if it's empty, you can't pop back anything, right? So you have to do a if top is, you could go either way. You could do the not equal to, or you could do the equal to. So you could say if top is equal to -1, then you would tell them printf stack is empty. You only need one message, so you don't need to put any curly brackets there. Else, open curly brackets. What we want to say is return what is at the top of the stack. Well, we'd assume that the name it, or we declare a stack here. This is C part 2 here, so we're using the same stack. So we send in what is at stack location top, and then do top minus minus. So you carry down the top by 1. When you carry down the top by 1, the stack will be, the next time you do a pop, it'll pop from the location that you need to. If it doesn't return, if it doesn't do anything, yeah, okay, let's return it up. I don't need to create a value. Should I create a value and then return the value after? Okay, let's return it one time. Okay, return straight from the stack, you know. Okay, I'll do the long way, so you'll be very clear as to what is happening. This is the long way. If you want to, you can return straight from the stack and nobody will get back to you. That's quite alright. But I don't want to give you a bad habit. Or I don't want you to put an answer that CXC doesn't accept. If you return directly from it, I believe they should accept it as an answer. I think you should just pass it one time, but that's okay. And then when the whole thing is finished, return value. Right. Okay, that's a textbook answer. That is exactly what they are looking for. However, I am 100% sure if you just return stack location top inside the else right here, that you will be okay too. So if you return everything one time, they should give you the marks, because it's how much marks? 5 marks? Yeah, you'll probably get 1 for declaring it properly, 1 for the if statement, 1 for saying that it is empty. That's 3. 1 for the top minus minus, and 1 for returning the correct value. Yeah, so returning the value inside should be okay. Okay. A single linked list contains 2 nodes as shown in figure 1 below. Explain how a new node with a value of 30 can be inserted. These explain questions in unit 2, they are annoying. I understand that you don't like them, and I don't like them either, but I understand that they have to teach you something. And in order to teach you something, what they're trying to teach you is to understand how these things work, not just regurgitate it. So if you understand how it works, you're going to have to explain it. Sad thing is we do have oral exams. So because they don't have oral exams, what you're going to do? You're going to have to write it. So, you would have to create a new node. So how much is 2 marks? Okay, create new node. 1, create new node with 30 in it. 2, point new node to previous first, which is 10. Then 3, point head slash top to new node. Right, so there's 2 marks. Usually it's a 3 mark question, but it's only 2 marks. Modify figure 1 to illustrate how this new node will be inserted at the top of the head as described in D part 1. So you create this new node here called 30. You take him and you point him there, and then you take this and point it there, and then you cross it out. So you show that you point the new node to the first node, and then you point the top to the first one and cross out the second one. Cross out the old one. 2 marks. That was a kind of weird 4 marks there. That looked like a 6-mark question, but I'm not really going to fight it. Yeah, that's what they're looking for, basically. Alright, cool. Question then. Following is a bubble sort function. It implements bubble sort algorithm on an array of integers. They give you a bubble sort. School. Explain the process that occurs in the inner for loop. Alright, this is where I usually have to warn students. A lot of the times people cram off bubble sorts. You can cram off a bubble sort and you may get a question that says, write a bubble sort, and you can write out the whole bubble sort, right? But because the amount of marks drop down and they're looking at more understanding than anything, you may need to understand how a bubble sort works, because more than likely the questions are going to be based on your understanding of bubble sort and not your regurgitation of memorizing the code. However, if you suck at understanding bubble sorts and searches and sorts and whatnot, memorize the code. At least I'll give you a fighting chance in some questions. But in this question, you have no fighting chance. So let's go. Explain the process that occurs on the inner loop. So which one is the inner loop? There is one loop here in a bubble sort. There's an inner loop and then there's an outer loop. So this we call this outer loop and we call this inner loop. Every sort has that. Bubble sort has it, an outer loop and an inner loop, and selection sort has it, outer loop and inner loop. And you have to explain how both of them works. Right, the inner loop, for 3 marks, what you want to say is you want to try to explain out what is happening line by line, but not like you're explaining line by line. So it starts like this. Inner loop, it traverses all the elements in the array 1p at a time. Yeah. Right, so this is the part here that's showing it traversing all the elements in array 1p at a time. If now we have to explain if what actually happening, right? In our bubble sort, if the bigger J index value is bigger, smaller. Bigger J index is smaller. Bigger J index, you could put on the right. That will save you a little bit of understanding. I don't know if they want to, how technical they want it to be. If you don't want it to use the word index, or you just could say on the right and on the left. I don't know, maybe they might accept it, right? So the bigger J index on the right value is smaller than the adjacent index on the left. My handwriting is so trashy. Add adjacent index on the left. The values are swapped, and then you will say this goes on, this repeats for all values, all indexes until max is reached. Yeah, until the max is reached, right? So it repeats until the max is reached. There are 3 marks. You really want to focus on the fact that it goes through all the values, it does a swap, and then it stops. Yeah. What can I add to this to make sure I get the marks by? I'll say swap using a temp variable. Yeah, maybe you might want that. So traverses everything, explain the swapping, and then say it keeps going on until it reaches to the end. Okay. Now you have to state why the upper limit for J in the for loop, because num items I minus 1 and not num items minus 1. And this one it's kind of difficult to explain in words. You basically want to say, what actually happening is that you're going from, you want to sort these two and then these two, but then when you sort these two, you don't want it to try to sort this one with something that is not there. That's why you have to go I minus 1, because you only want to stop swapping up to this part right here. If you want to stop swapping up to this part here, that means you have to tell it, okay, J could only reach up to this part because J has to compare with this one right here, right? So basically you're trying to explain that J compares, like that J compares with the next value that's on top of it. However, J can't go to this value here because there is no value to compare to the top of it, right? That's the explanation. To put that in words, I personally find it difficult. But we'll say something like to allow you to scan the remainder of the array without swapping, without comparing past the last index. Right? That's the best way I could say it for 1 mark. I think it should be a 2 mark, but yeah. Right, so this for loop will go for I less than num items minus I minus 1. That means you won't go further than you're supposed to go. You technically want to not try to resort unsorted items, already sorted items. Yeah. Long story short. Yeah. Alright, the array below shows how 5 integers are stored. Using the bubble sort algorithm, show the contents of the array after each of the first 4 phases of the sort. I'm so glad that they gave you the boxes to fill in here, because usually back in the day you had to fill in these boxes for yourself. That's not cool. That's not cool. Alright, so a bubble sort will start off after the first pass. A pass means that it has to go through all the items. So what will happen is there'll be a swap here. No, there'll be a comparison here, then a comparison there, then a comparison there, then a comparison there. So what will happen in the first pass is 5 will swap with 1. The 1 and the 5 will swap. But with the 5 will end up comparing with the 4, and then the 4 will end up swapping in. And then the 5 will end up comparing with the 8, and the 5 stays there, and then the 8 goes there, and the 2 goes there, right? So that's 1 pass. AKA, what happened is, just to be very clear, the 1 and the 5 swapped. But when the 5 reached here, the 5 was like, hey, 5 and 4, who is smaller? The 5 and 4 say to each other, I'm smaller. So then the 4 ends up going here, and the 5 ends up jumping over here. So the 5 ends up jumping twice. That's what happens. And then the 5 tries to compare with the 8, and the 8 says, no, I'm bigger. So therefore, I stay there, right? So we have to repeat this process again. However, the 1 is locked in place. So the 1 will always be there, no questions asked. That's locked in place because the smallest value has reached to the end. 4 and the 5, not going to unswap. 5 and 8, they are going to swap. Not going to swap. The 8 and the 2 are going to swap. So the 2 and the 8 will do like that. And then we're going to lock the 1 and the 4 in place now. No, sorry. Yeah, they're not going to lock in place. Sorry. Yeah, my bad. So what happens is the 1 reaches down to the end. Great. Wonderful for the 1. The 1 is locked in place. So now the 4 and the 5, they are going to ask each other, are we going to swap? And the 4 and the 5 say, nope, we're not going to swap. Cool. So the 4 will stay there. And then the 2 and the 5 will swap. So the 2 will go there, the 5 will go there, the 8 will go there. Right. And then on the last pass, the 1 will be in place. The that's not confusing myself. Ow. Oh, sorry. In this first one here, the 2 would have ended up swapping with the 8. Yeah, my bad. Right, good. Good. Right. So now I'm back to my understanding. To try to rush through this, eh? You have real time in the exam, so don't do like me there and try to rush through it. Right. So the 1 is locked in place now, like that. So now we have to figure out where the next one is going to lock. The 4 and the 5 are not going to swap. So the 4 will stay there, but the 5 and the 2 will swap. So the 2 will swap with the 5, and the 8 will stay in place. Why has it not finished swapping yet? Because, well, the 8 has reached the end. Right, because bubble sort locks at the end, right? Good. So the 8 reached the end, the 5 and the 8, they're locked in place now. So there won't be any swapping there, because you don't want to continue swapping items that's sorted already. 4 and the 2, they're going to swap. So you have 1, 2, 4, 5, 8, and this will lock that in place. And then the 1 and the 2 are going to compare with each other. The 1 and the 2 are going to be like, we don't need to swap. So 5, 8. Yeah. That should make your question the answer. You put here to allow you to scan the remainder of the array without comparing past the last index or last index or last sorted index. I'll put last sorted index. Yeah. Right, that makes the explanation a little easier, because what we did here is you realize this lock. So this is where the I is equal to I minus j kind of happens here. This make sure that you stop trying to sort past the value that you're supposed to go up to. Yeah, right. Whew. This was a hard 1 mark to ask for, but I guess you understand now. Number part B. Explain what is involved in a linear search. A linear search, wow. a linear search traverses all the records in an array, all list of items, because it could be a linked list, and compares each value to a search value. If the value, there should be a new sentence, yeah. If the value is a match, the index is returned. Otherwise, the return value is -1. Yeah. How much did I ask there for? 3 marks? Yeah, the linear array. Yeah. This is assuming I do it as a function. If you return -1. But if it's just if it's in the code, then you will you work it out. But return -1 is usually good. The following 9 integers are stored in an array. Describe how a binary search algorithm will search array for the key 16. Alright, what's the key 16 here? 16 is here, right? Okay. So we're going to start off by the midpoint is found. You're explaining a binary search here. It would help if you write out a binary search on the left hand side and be like, okay, blah blah, binary search, you find mid is equal to low plus high, alright, divided by 2. So you could write out all of that drama, or you could just do it. So you could say the midpoint is found, midpoint index is found by adding 0 plus 8 divided by 2, which gives 8 divided by 2 is 4, which gives 4. The value 27, which is at index 4, is compared with the number 16, and there is no match because 16 is less than 27. High is changed to mid -1, right, which is index 3, which will be here. So we'll cut off that size in it. The new mid is index 1, which is 9, no match. Low becomes index 2, and new mid is index 2, match found. Index 2 is returned. In the past, this question would have been probably like a 6 marks or 7 marks, but for it to be 4 marks, I'm not too sure how they wanted you to write it with those short amount of lines. Maybe they just wanted you to point out what the mids are, but they say describe how it will search, so I am not going to give them any opportunity to make them think that I don't know what I'm doing. So what you want to do is you want them to understand that you know the crux of a linear search is midpoints being compared to a value. If the midpoint value is compared to the value that you're searching for and it's correct, return that location. Otherwise, find a new midpoint. So you move your low and your high up, sorry, find a new midpoint. Move your low and your high up, find a new midpoint. Move your low and your high up, find a new midpoint. And then, yeah, it's a lot of work to write it out. But I promise you, they usually ask for weird things. Alright, so that's section 1. That's 2 15-mark questions. Shouldn't have killed you too much. Yeah, that wasn't a bad section 1. Wasn't bad at all. They didn't ask anything about sorting. Yeah, so just searches. They asked for one. Yeah, they just asked for. No, they didn't ask anything about a selection sort. But they did get a binary search. They didn't do a selection sort. Yeah, that's the only thing they left out. Selection sort.